Hello everyone, welcome to Helm of Science. So we have started off with this question answer revision series in our channel, just covering all the topics that can have probable questions in your competitive exams. So as we know that the upcoming joint entrance examinations will take place and it might take place in very near time. So our preparation should be up till that level. Our preparation standards should be doubled and we should be preparing with equal gusto. Since the examinations are just knocking at the doorstep, so I thought that to cover certain topics which generally uh, children or students have a tendency to ignore, ignorance basically on the fact that they find the topic difficult or they don't know how to approach the questions. So, in that retrospect, I have kind of jotted down certain questions from the chapter Thermodynamics, which is a chapter that is common in both physics and chemistry, though the formula, working formula might be a little different, but then the topic is common in both, so it will serve the purpose in both the cases. So without doing further any kind of talks or any kind of chit chat, let's just start off with the topic. So the first question that I have jotted down here is the difference between delta H and delta U when the combustion of 1 mole of heptane is carried out at a temperature T is equal to. So first things first, this difference of delta H and delta U has a formula that I will write down, which you should be knowing for your exams, and it is very important. There are two formulas basically. One is delta H equal to, just a moment. Okay. So I think it's clear right now, the screen. Delta H is equal to delta U plus NGRT. This is one formula. Another formula is delta H equal to activation energy plus NGRT or NG minus 1RT. These are the two formulas I would say that is very important for the examination point of view. Alright, so we have to deal with this one because that's what the question requires. What does the question say? It says that heptane has been combusted, right? So any molecular compound, or rather any hydrocarbon, when it is burnt or combusted in oxygen, the only two products possible are carbon dioxide and water, right? So just let's write down that if heptane is combusted in oxygen, then we will be getting carbon dioxide, which is a gas, and water, right? So, question is that should we balance it? Yes, you have to balance the question, otherwise, the equation rather, otherwise there will be problems. So the balancing comes out to be 11 for oxygen, 7 for CO2 and 8 for water. Just verify the balancing when you do the question once again, but this should be the answer. Alright. Now, second question, that in this equation, we have understood that this stands for enthalpy, this stands for internal energy, R is the universal gas constant, T is the temperature. Then what is this? N stands for moles. We have already used the word or the alphabet N for calculation of moles right from the beginning of class 11, right? So that is there. Now, why the G? We have to calculate the change in the gaseous number of moles in the reactant as well as in the product. And repeat once again, you have to calculate the change in the number of moles from the reactant to the product. Clear? So how do we do that? Okay, now gaseous reactant is what I've mentioned, that is why the G. So on the product side, the gaseous products are only carbon dioxide. That has how many moles? 7, right? And on the left hand side, the gaseous reactant is oxygen. So that has how many moles? 11. So whenever we are finding out a change, we always do product minus reactant, right? So this is the answer. Now just put the values in the equation and you should get the required answer. So let's just proceed. Delta H minus delta U is what we have been set to calculate, should be equal to delta Ng RT. To substitute the values, minus 4 into R you would be taking. Actually, it's not required, because if you see the options, they have not replaced the value. They have just kept it this way. So your answer would be minus 4 RT, which is option number A. So is it clear? If you had to hypothetically put the values and calculate an answer, what would you have done? Just put Gratz constant value as 8.314 if and only if the change is asked in Joule. If it is asked in liter atmosphere, go ahead with 0.0821. If it is asked in calories, then the value should be 1.987. But for the calculation's sake, since you are not given a calculator, take it as 2. Round it off as 2. Alright. And if temperature is mentioned, well and good. Just convert it into the Kelvin scale and put the value. But if no temperature is mentioned, then take the normal temperature and pressure value, that is 25 degrees centigrade or 298 Kelvin. Yeah, super. Now moving on to the next question, it says a process will be spontaneous at all temperatures if, and there are 4 categories to support it. Right? So whenever you are preparing for a competitive exam, one thing you should keep in mind is we cannot go through all the formulas at the same time, all the options at the same time. Because if we start thinking about each and every option in the deepest level or deepest scale, then there are maximum chances that you will get confused. So the only target or the only, the trick to qualify a competitive exam is eliminate options. Try to eliminate your options. Try to cancel out the options which are 100% not possible. And then you try to arrive at your particular answer. Alright. So what do we know about spontaneity? A reaction is spontaneous when there are 2 criteria, right? One is your delta G, that is Gibbs free energy, should be negative. This is the primary criteria for the reaction to be spontaneous, right? Now coming to randomness, since it is mentioned here, there are 2 values mentioned. Delta H and delta S have been given in different forms. Considering the delta S, that is the randomness part, what is it? Randomness is how fast a gas molecule moves, right? That is randomness. The more the randomness, the more there will be the reaction occurring, the more fast or more speedily the reaction will be occurring. So, in that case, randomness should always be positive for the reaction to at all occur. Just by this assumption or this outcome, we can cancel 2 options. Which are the 2? The option A and B, because both of them say that delta S should be less than 0. Now this is never possible. If delta S is negative, then there is no randomness in the system. So forget about a reaction taking place. If the molecules do not move randomly, if they do not collide, how on earth will the reaction take place? Right? So that is not going to happen at all. So already just by a small application of our knowledge, we have eliminated 2 options. Now we are left with other 2 options in which both of them say that delta S should be positive. So now we have to separate it out in some other logic. So the logic is, we know delta G is equal to delta H minus T delta S, right? Now considering if delta S is positive, right? So this entire T delta S part is positive, right? So we have a minus sign before it, so we will get a negative value from here. In order to for delta G to be negative, what should happen? This minus portion up till here should be greater than the value of delta H. Then only you will get a negative value, and then only we can conclude that the reaction is spontaneous. Yes? So delta H value should be much lesser than the value of T delta S, so that the entire value of T delta S comes out to be negative, justifying our criteria. Right? So delta H should have a value of less than 0 in this case. Why? Why not greater than 0? Because if it is greater than 0, they have not mentioned a value. What if, suppose I am saying that Suppose the value of delta S is positive, right? So it is about 10 times. 10 and temperature is supposed 298, hypothetically, right? So this value comes out to be 2980, right? Considering delta H to be positive by this criteria. But we have not mentioned what the value is. What if the value is 3000? What happens? The net delta G becomes positive, so that should not be our case. So in this case, we will always mark option number B, which says delta H has to be negative so that the entire thing comes out to be negative. Delta H would have been positive if the value was given to us. That what range is it in? Right? So in this case, the safest option would be delta H less than 0. Clear? Okay, moving on to the next question. The next question says 5 moles of an ideal gas at 100 Kelvin are allowed to undergo reversible compression till its temperature becomes 200 Kelvin. If CV is to 28 joule per Kelvin per mole, calculate delta U and delta PV for this process. Okay, now for this question, what will we do? We will do is, it's very simple. First things first, whenever you're solving a problem, write down the given values. So N is 5 moles, right? Temperature was T1 was 100 Kelvin and T2 is 200 Kelvin. Correct? Now, CV has been given to you is 28 joule per Kelvin per mole. Now, how can you calculate delta U here? Very simple. Delta U equal to NCV dt, or in this case delta T, right? So delta U would be 5 into 28 into change in temperature would be 200 minus 100. This should be 5 into 28 into 100, giving us 14,000 joule, or we can write it in the form of kilojoule because the questions have been given in that manner, the options. Alright, now we have told that we have to calculate delta PV. Now, for an ideal gas, since it is mentioned so, work done is equal to PV, right? So, we may write it as work done is equal to delta PV, right? Change in pressure and volume. So, now how do we calculate the work done? Delta PV we cannot use right now because we do not have the pressure as well as the volume values. So, what can we do? We can write it as NR delta T. Now, question is, you might ask me, ma'am, why not this? Now, putting delta in front of all these three parameters indicates that R changes, but R is a universal constant, so that cannot change. Coming down to number of moles, there has been no change in the number of moles, so you cannot put a change sign or delta sign before it. So, the only thing that has changed is temperature. That is why we have put that value. Alright, now 5 into 8.314 into delta T is 100. Right? 200 minus 100 making it 100. Right? So the answer would be 4000 joule, or rather 4 kilojoule. Now your option matches to 4 kilojoule and option number C. Right? Now in this context, I want to mention something. Although the other option is not matching, but still, if you visit option number B, you will see delta U is given as 14 joule, right? Now, in the exam, see the other value is not matching, so it's safer. But then still, what happens whenever we are doing or giving an exam, we tend to skip certain things, notice certain things. That the basic thing is the unit. Whenever we see that we have matched the value, okay, we blindly tick the option. But that should not be the case. You should always look for the units as well, whether they have messed up the units or they have played with the units or not. Alright? Okay. Moving on to the next question. The standard electrode potential E0 and its temperature coefficient for a cell are given at 300 degree Kelvin. The cell reaction is mentioned. The standard enthalpy is how much? Right? This is the question mentioned. So, how would we approach this question? Now, this is a question. I don't know whether this concept has been taught to you or was it there in your board syllabus, but in terms of joint, as far as joint is concerned, it has a formula which makes the question very easy. The formula is, you can just write it down or note it down. There are two formulas actually, one for delta S and one for delta H. The one for delta S is NF into dE dt at constant P, where change in EMF with change in temperature at constant pressure is your temperature coefficient, right? And what is delta H? How is it written? It is NF T into dE dt at constant P plus E, where E is the EMF. Okay, this is the formula for delta S and delta H, which you should be knowing for your exams. All right. So how to solve it? Now, what is mentioned? Okay, this is easy, right? What is mentioned is delta H is mentioned to you at 300 Kelvin. Oh, you have to find it this out. Okay, number of moles is it mentioned? Okay, now this is not number of moles here. Why? Because F stands for Faraday, right? Which has a value of 96500 Coulomb, right? So N here stands for number of electrons lost or gained in that particular reaction. So the reaction that is mentioned to you is zinc to Zn2 plus and copper 2 plus to copper, right? So in both the cases there is a 2 electron transfer, so your N value should be 2 here. Then 96500 is the Faraday. Then what did you have? T into ddt at constant P. So the temperature mentioned to you is 300 Kelvin, and the temperature coefficient mentioned to you is minus 5 into 10 to the power minus 4. Okay, and plus E, the EMF is mentioned 2 volt, right? So let's just calculate this. What would you get? You will get is minus 1500 into 10 to the power minus 4 plus 2, which makes it 9 into 2 into 96500. 15 into 100, so that should be 10 to the power minus 2. 15 divided by 100 would be 0.15, right? So minus 0.15 plus 2. If you follow and do the correct calculations, your answer should come out to be roughly at around, it should be minus 412.8. This should be your answer. Okay, and it is in kilojoule, of course, right? Okay, now one thing I needed to mention is, which I think I have not mentioned in the formula. Let me just check. Yeah, this should be minus NFT into d dt at constant P plus. Alright, so mention that minus in the question. Correct? Moving on to the next question. The next question says, a piston filled with 0.04 mole of an ideal gas expands reversibly from 50 ml to 375 ml at constant temperature at 37 degrees centigrade. As it does so, it absorbs 208 joule of heat. The values of Q and W are. So whenever you see temperature is a fixed temperature, ideal gas is expanding reversibly, so your work done should come out, your first hint should be, the work done formula should be minus nRT ln V2 by V1. This should be your first hint when you see such kind of a question. So let's just put 0.04. We have to find it out in joules, so 8.314 it should be the value, but just for the simplicity of calculation's sake, I am doing it 8 here, and you should be following that as well in your competitive exam, since your calculator is not allowed. 37 degrees centigrade, meaning that should come out to be at 273 to 37. How much is it? Okay, now this part you should always remember that you have to convert it into Kelvin, not in degree centigrade. You should not use the value in degree centigrade. So the final volume is 375 and the initial volume is 50. Right? Now, this should come out, it's 50 and 375, right? So minus 0.04 into 8 into 310. If you calculate this out, so this should come out to be around 7.5, ln of 7.5. That value is already mentioned to you in the question, right? So just substitute the value of ln 7.5, that is 2.01. Okay. So when we do the calculation, we would get minus of 208. This should be your answer. Now, the second part of the question says that it absorbs 208 joule of heat. So your Q should be, when it is absorbing, so it should be a plus, right? So your answer should be Q is plus 208 joule and W is minus 208 joule. That corresponds to the option A, right? So step by step, you have to approach a question. Do not rush with any questions. Otherwise, there are maximum chances that you're going to end up ruining the process as well as the question. Alright. Now the last question is a very interesting question from my side. Is how do you predict a graph? How do you see a graph and predict your answers corresponding to that graph? Okay, so let's just start it. See, first I'll just draw the graph, whatever is mentioned and whatever is given. So the graph gives you a plot of P versus V, that is volume, and one isothermal process, one adiabatic process. Isothermal meaning temperature constant, and adiabatic meaning there is no heat absorbed or lost. Heat change is zero, right? And some pressures and volume and temperature is given. This is supposedly P2, V2, T2. And I think this is P3, V3, T3. This is the thing. You have to find out which of the options are correct. Now, first things first, just as I mentioned to you, that isothermal means temperature is fixed, right? Temperature constant. So, whenever you're following the isothermal path from this to this, whether it is T1 or T2 or T3 or whatever, in that isothermal process, the temperature should be fixed. So, your first answer should be T1 equal to T2, which makes you come to option number A. That is correct. Now, coming back to the C and D option, there is a notion or there is a concept that work isothermal is always greater than work adiabatic. Now, you will ask me how. So, let us consider that the final volume is constant. The final volume for both adiabatic and isothermal is constant, and that is V2. Okay. So, what can we write down? We can just follow a diagram like that or a comparison. So, in case of isothermal, starting from P1, V1, our final volume is V2. Let the pressure be P isothermal when the volume is V2. Concentrating for adiabatic, it starts from P1, V1, final volume is V2, and the corresponding pressure is PA. Right? Now, for adiabatic, we have an extra factor, which is gamma. Right? So, P1 by PI should be equal to V2 by V1. P1 by PA should be equal to V2 by V1 to the power of gamma. Now, since this value of gamma is present, right? So, this V2 by V1 value will be greater than this V2 by V1 value. So, we can write P1 by PA greater than P1 by PI. Now, P1 is fixed, right? That is the initial pressure. So, we can write 1 by PA greater than 1 by PI. Now, if we just inverse the thing, we can write PI greater than PA. Now, we know work done is equal to PV or PdV, whatever. So, work done is dependent on pressure. Now, if the pressure of isothermal is greater than adiabatic, so work isothermal should be greater than work adiabatic. This brings us to the conclusion for B. One second. For C, option number C. Now option number D is also correct. Why? Because of the first law. First law states that internal energy is equal to heat plus work done. So inadvertently, internal energy is dependent on work done. So if work adiabatic is less than work isothermal, so obviously delta U adiabatic will also be less than delta U isothermal. So that brings us to option number D. So what have we got? We have got A, C and D options absolutely correct. Now your question might be that why is the second option not correct, which says T3 is greater than T1? For that we need to check the diagram once again. T3 is the final temperature in the adiabatic process and T1 is the initial temperature of the adiabatic process. Okay. Now, using our basic concept, adiabatic processes bring about cooling. Right? Adiabatic processes lead to cooling. Right? Except for hydrogen and helium. Except for hydrogen and helium, in all other cases it leads to cooling. So if it leads to cooling, then temperature T3, that is final, should be less than initial. But it is mentioned just the opposite, right? T3 is greater than T1. So that should not be the case. So option number B is not correct. So that makes us or comes to the conclusion that options A, C and D are your correct answers for the question, right? So I have discussed the different concepts of thermodynamics. Rather, it would be better if I say that I have discussed different genres of questions that can come from thermodynamics, so that you know all the formulas. You know the formulas where generally question comes from. Uh, that is what I've tried to do in the 5 or 6 questions that we have discussed today. In the next class, we shall be discussing about any other new chapter. Till then, if you have any questions regarding to any of the problems that I have solved here, let me know. And if you have any suggestions to make as to which question series should I be doing next, that also let me know. Alright, till then, stay safe, keep revising, and happy learning. Thank you.